Hello everyone, once again welcome to our physics class. Hope you all are fine over there. So in the previous session we had discussed the change of state and calorimetry. Also we discussed about regulation. Today we are going to discuss different modes of heat transfer. Heat transfer. What do you mean by heat transfer? Yeah, the transfer of heat due to temperature difference. And you know, you had already studied from your lower classes. Whenever there is a temperature difference, heat starts to flow. And heat usually flows from a hotter body to a colder body. So this heat transfer occurs due to temperature difference. And there are mainly three modes of heat transfer. One is conduction, second one is convection, third form is radiation. So let's discuss each of these modes one by one. Conduction. Heat transfers between two adjacent areas of a body due to temperature difference. Okay, heat transfers between two adjacent areas of a same body due to temperature difference. See, you have a candle here and you show a copper rod near to the candle. So let this end be A, let this end be B. So the end A of the copper rod gets heated up quickly and it is now the hotter end. Now end B at the same time is the cold end. So a temperature difference has been created between the ends A and B of the rod. So as soon as a temperature difference is created, heat starts to flow from hotter body to colder body. So there is a flow of heat from A to B. So here heat transfers from A to B. That means heat transfers between two adjacent areas of the same body due to temperature difference. So this type of heat transfer is known as conduction. And heat conduction can be considered as time rate of heat flow. Time rate of heat flow. At steady state, the time rate of heat flow is proportional to temperature, area and inversely proportional to length. Okay, so heat conduction can be considered as time rate of heat flow, and at steady state, the time rate of heat flow, that is H, is directly proportional to temperature, that is this temperature change, and it is also directly proportional to area, at the same time inversely proportional to length of the conductor. And this proportionality symbol can be removed by adding a constant, and that constant is K. So H is equal to K A delta T by L, where K is called thermal conductivity. So what is K? K is thermal conductivity here. And its unit, the unit of K is joule, second inverse, meter inverse, Kelvin inverse. Okay, so this is the unit of thermal conductivity K. And some applications of conduction can be explained here. Some cooking vessels have copper coating on its bottom. Do you know the reason? Yes, because of the high thermal conductivity of copper, it distributes heat over the bottom of the pot very quickly and promotes uniform cooking. This is the reason some cooking pots have copper coating on its bottom. What is the reason? Because of the high thermal conductivity of copper, it distributes heat over the bottom of pot very quickly and promotes uniform cooking. In the house also with a concrete roof, a layer of insulation is made on the ceiling to prevent heat transfer and hence to keep the room cooler. Okay, the next we can discuss about convection. So what do you mean by convection? In convection, different parts of the fluid moves from one point to another point. And convection can be natural or forced. In natural convection, not convention, it is convection. In natural convection, when fluid is heated, it expands and becomes less dense. When it becomes less dense, it rises up and colder part replaces it. This process goes on as a cycle. Okay, sea breeze, the natural phenomena such as sea breeze and land breeze can be explained on the basis of convection. So in a convection, different parts of the fluid moves from one point to another. So why is it so? Because suppose this is a burner and we have placed a cooking pot here. It is filled with water. We can see this layer of water, it is close to the flame, so it gets heated up quickly, and when it gets heated up quickly, it becomes less dense, and the molecules here becomes less dense and it goes up. When the density decreases, it will rises up, and when it rises up, the colder layer of water here gets replaced here. Okay, so this process goes on like a cycle. So this is convection. And land breeze and sea breeze can be explained on the basis of this convection. So what do you mean by sea breeze? First we can discuss about sea breeze. What do you mean by sea breeze? During the daytime. So sea breeze occurs during daytime. So that is the important point that you want to remember. Sea breeze occurs during daytime. Okay, during daytime, land gets heated up quickly than water. So suppose this is land and this is sea. Now, and during daytime, land gets heated up quickly than water. So when the land gets heated up quickly, the air above the land becomes less dense. It will rises up because its density is less. As soon as it rises up, what happens? The cold air from the sea replaces this vacancy. Okay, so the cold air from the sea replaces this part, occupies this vacancy, and the warmer air from the land flows to the sea. So this cold air flowing from the sea to the land is known as sea breeze. Okay, the cold air which flows from sea to land during daytime is known as sea breeze. But at the same time, during night, what happens? So again, during night, land breeze occurs. Okay, during night, land breeze occurs. So same examples, here it is land, here we have sea. So during night time, the land loses its heat quickly than water. So that is a property of the land. It gets heated up quickly, at the same time it loses its heat quickly. So land is now cold and sea is now hot. Why? Because water does not lose its heat quickly. So now the air above the sea is hotter than the air above the land. So this air becomes less dense and it will rise up. And as soon as the vacancy is created here, the cold air from the land replaces this vacancy, occupies the space or the vacancy created by this air above the sea. So this process goes on like a cycle, and here the cold air flows from land to sea now, and this is land breeze. So sea breeze occurs during daytime and land breeze occurs during night time, and it is explained on the basis of convection. And the third mode of heat transfer is radiation. In radiation, energy is transferred in the form of electromagnetic radiation. Example, Earth receives energy from the sun by radiation. So here, medium is not required. In the other two cases, that means in conduction and convection, we can see a medium is required for the heat transfer. But for radiation, medium is not required. That is the difference. Okay. And some examples or some applications can be discussed now. The utensils for cooking purposes are blackened at the bottom. Why? Because black color absorbs maximum heat from the fire and it fasts up cooking process. So that's why utensils for cooking purpose are blackened at the bottom. Black color absorbs maximum heat and hence it fasts up cooking process. And what do you mean by black body radiation? A black body is one which absorbs radiations of all wavelength, and the wavelength emitted by a perfect black body is called black body radiation. Okay, so what do you mean by black body radiation? A black body is one which absorbs radiations of all wavelength, and the wavelength emitted by a perfect black body is called black body radiation. So let's discuss about the energy distribution in a black body radiation. Energy distribution can be explained on the basis of this graph. Here you can see this is the peak of this graph, and this is lambda 1, and this is the peak here, lambda 2, this is the peak here, lambda 3, and different temperatures T1, T2, T3. Here we have plotted energy, here we have plotted lambda. Along the x-axis we have plotted wavelength lambda, and along y-axis we have plotted energy. So in order to study about the energy distribution in a black body, these two scientists, that is Lummer and Pringsheep, performed an experiment to study the distribution of energy in a black body at different temperatures. So the result of the experiments are plotted in the form of this graph. So what is the result? For a given temperature, energy distribution is not uniform. That is very clear from this graph, isn't it? The graph is like this. So what happens? The energy at first increases, becomes maximum, and then decreases. So it is very clear, for a given temperature, energy distribution is not uniform. And the energy associated with both longer and shorter wavelength of radiation emitted is small. So if you consider this graph, this portion represents the energy associated with the shorter wavelength, and this portion represents the energy associated with the longer wavelength. That means two extreme portions of the graph. And the energy associated with two extreme positions, that means with the shorter wavelength and with the longer wavelength, is very small. And for each temperature, there exists a particular wavelength corresponding to which the energy is maximum. That is very clear here. If you consider this graph, for this particular wavelength, that means for lambda 3 wavelength, the energy of the graph is maximum. And if you consider this graph for temperature T2, here also corresponding to the wavelength lambda 2, there is a peak. So that means energy is maximum at lambda 2. And for the graph at temperature T1 also, you can see a peak at lambda 1. That means at lambda 1 energy is maximum, isn't it? So for each temperature there exists a particular wavelength corresponding to which the energy is maximum. And this maximum energy carrying wavelength decreases with increase in temperature, because this maximum wavelength is inversely proportional to temperature. Okay, now that we can see here, see for temperature T1, lambda 1 is the wavelength. Okay, that is very high value. But T1 is the smallest temperature here. And again at a higher temperature T2, the maximum wavelength lambda 2 value decreases. Again at a little bit higher temperature T3, this is the highest temperature T3, the peak value lambda 3 again decreases. So as the temperature increases, the wavelength, the value of the maximum wavelength decreases. And also the area under each curve represents the total energy emitted by the body at a particular temperature. So if you consider this curve for temperature T1, this is the area under the curve, isn't it? And the area under this curve at temperature T1 gives the total energy emitted by the body at that temperature. Similarly, area under the curve for T2 gives the energy emitted by the body at temperature T2. Okay, and this area increases with increase of temperature. That is true. For temperature T1, only this is the area, but for temperature T2, this whole area, for temperature T2, we have this whole area, and for temperature T3, this is the whole area. So as temperature increases, the area also increases. So energy also increases. So energy is directly proportional to temperature. In fact, energy is directly proportional to the fourth power of temperature. Okay, so that's all about the conclusions of experiment performed by Lummer and Pringsheim related to black body. The conclusions or the result of the experiment are given here. You can pause the video for a while and you can note down the conclusions or result of that experiment. So children, that's all for today's session. Notes of the topic and YouTube video have been uploaded. Please go through it. We will meet in the next session. Till then, take care all of you. Stay home, stay safe. Thank you.